1, 2, 1, 2, 3, 4.
Dispersion of white light. What happens when a beam of white light strikes a prism? When a narrow beam of ordinary white light is passed through a glass prism, different wavelengths travel through the glass at different frequencies and appear as a continuous broad band of different colors, called the spectrum. This phenomenon, by which a ray of light splits into its constituent colors when it is passed through a transparent medium, is known as dispersion.
Diffraction of light. A ray of light bends slightly as it passes around the edge of an object. The phenomenon of bending of light from its straight line path around the corners of an obstacle or slit is known as diffraction. Diffracted light can produce fringes of light, dark or colored bands. Drag the slider to observe how the quality of diffraction changes with the change in the size of the slit. We observe that the process of diffraction becomes much pronounced when the dimensions of the slit are comparable to the wavelength of light. At times, diffraction of sunlight in clouds produces a multitude of colors. This optical effect is called cloud iridescence.
Interference. We know that the two mechanical waves of the same frequency can interfere constructively if peaks of these waves are traveling in phase, and destructively interfere if the waves are not in phase. Similarly, light waves also interfere with each other as shown here. Light waves interfere only when the electromagnetic fields that constitute the individual waves combine. The interference pattern thus obtained contains alternate zones of maximum and minimum intensity called fringes. Thus, interference of light is the phenomenon of the non-uniform distribution of resultant intensity when two light waves from two coherent sources superimpose on each other. The colors are due to the interference between light rays reflected from the front and back surfaces of the thin film of soap making up the bubble. The colors depend on the thickness of the film, ranging from black, where the film is thinnest, to red, where it is thickest.
What I have here is a plastic material where the crystals, the molecules that make up the material, are arranged in this direction. And if you look carefully here, you can see there's a line which tells you how the crystals are arranged. And here's another one. It's just like that. Both lines are the same. So if I put the two crystals over each other, you can see through them. But watch what happens if I rotate one of these crystals. Wow, it got dark, didn't it? See, what's happening is that the light that comes through this one is in this plane. The other crystal, when I had it the same way, would also allow that to happen, but when I turn it like that, it blocks the light.